Okay, this is our molecule, which is pinacol. Its molecular formula is C6H14O2. It has one functional group, which is the diol, which means that it has two alcohol groups on it, which we can see right here and right here. It has 0 degrees of unsaturation, so there's no double bonds or rings in this structure. And it has 21 sigma bonds, which we can see through all of these single bonds right here and all of the bonds to its respective hydrogens on these carbons on the end. It has 6 sp3 hybridized carbons, which means they're all single bonded to each other, which they are. It has 2 unique carbons, so this is one unique carbon right here and one unique carbon right here. And these are the other groups of unique carbons. And the hydrogen ratio is 12:2, which we can see there would be one hydrogen bond coming from right here and the other one coming from right here. And these carbons on the end would have 3 hydrogens each attached to it, which is where we get 12 from. And it has the heteroatom oxygen, which we've already talked about from the diol functional group. Okay, now we can go ahead and start assembling our pinacol molecule, and here's its molecular formula. I don't know how well you can see it on there, but this is C6H14O2. So I'm gonna go ahead and start with, we have 4 methyl groups in this, so that just means like a CH3. So I'm gonna go ahead and start by making our 4 methyl groups. And it just looks like this, and each of them has a sigma bond right here with each carbon molecule. So there's one. This is our second one. Our third one. And our 4th one. And now I'm gonna go ahead and make these 2 alcohol groups right here. So every alcohol group will be represented by 1 carbon, this black molecule, and then 1 red molecule, which is our oxygen, and then 1 hydrogen molecule. So here are 2 alcohol groups, and then these 2 will be attached, and then these methyl groups will be attached to these carbons. So from our methyl group, we have 1, 2, 3, 6, 9, 12 hydrogens, and then these are our 14 hydrogens right here, and then our 2 oxygens right here, and then our 6 carbons, 1, 2, 3, 4, 5, 6. And then all of these are just snapped directly onto each other because they're all sigma bonds. So the 21 sigma bonds are present in here too, no pi bonds. Because they're all sigma bonds, there's also no degrees of unsaturation in here. And then this is 1 unique carbon right here, and this one attached to the oxygen is another unique carbon group. So this is 1, and then these 2 are unique ones right there.